Okay, stream is transitioning. Agenda is in the chat. And let me pull up these this YouTube chat box so we can talk to people. Let us know on YouTube when the stream has transitioned. Okay, cool. So go ahead and get started. Issue 112, our 30th call. First thing, testing and release updates. We did release V093, which had some substantive changes to state transition and networking. Nothing crazy. Check it out. I forgot to get out something important in the networking in that PR, namely adding a attestation subnet bit field to the ENR. This ends up being backwards compatible with the previous method of guess and check and fully connecting the peers to see if they're on a subnet. So I am going to release this probably today in a V094. The BLS standards integration has gone through a couple of iterations. There is a good PR, I reviewed it. Looks like that's going to be merged in very soon into dev, at which point we will release that probably first week of, because I'm not really waiting on anything, but certainly by the first week of January. We are undergoing a pretty comprehensive audit of Phase 0 with lease authority. I'll do an official announcement probably at some point today. And we're going to use that V010, well, V010 as the target for that. So that's what's coming up there. I have continued to fail to deliver on fork choice tests. I know there is some work still going on by Harmony on that. Mikhail or anyone from Harmony want to give us an update?
Yeah, sure. Alex just filed an issue in the spec test repository. Let me just paste it here. This is like a issue with the format for that we propose for a fork choice test, and it also contains some already generated vectors. We have finished like a beacon data processor implementation that is very close to the spec, and it handles things like delayed attestations, which are just queued and applied later on. All of this is could be useful for generating comprehensive scenarios for the fork choice, and we think that integration test approach for the fork choice is very important thing, because it could like find some issues with that with the integration of the fork choice that are not covered by the spec, and could lead to slight like I don't know slightly different view of the chain on the chain in different client implementations. So we will Alex is working on the generator so far, and once we have this format approved, we can just like generate more test vectors and probably integrate them with the PySpec later on. So yeah, the work is in progress, and we have some vectors already generated. That's great. Yeah, so
that's awesome.
Working on that.
Thank you. I will review that today, and if a couple other people from some of the client teams want to take a look at that, wrap their heads around the format. Yeah, product.
Sorry, can you link the code that generates them? This is the most interesting part, since it's this trade-off between very verbose and like almost handwriting the tasks to something that's very abstract and very nice. And then you'll have to build a lot of framework in here. So I'm interested in the approach you're taking here.
The approach is like just to feed this beacon data processor with some data like attestation and blocks and slot ticks and get the output. That's it. And yeah.
Can you link to that
So there
on
is
the test issue?
Yeah, sure. I guess there is no. Alex is working now on separating generators code from like the from processing code. So yeah, I'll link it in the issue, but it's not yet ready.
Gotcha. Thank you. Mehdi, I think you had an update for us, right?
Absolutely. Hey, everyone. Lots of cool progress in the last few weeks on Beacon Fuzz. So all our fuzzers are now matching version 9.1 of the spec. We'll be upgrading to 9.3 or 9.4 once at least 3 clients have implemented it. I know we, and by we I mean the Lighthouse crew, won't be implementing it until the first or second week of Jan. I'm not sure about the other teams. In other news, we've integrated Python sub-interpreters to allow us to have multiple Python interpreters per process. So we're using them to basically keep the different Python implementations isolated with respect to their dependencies and global states. And this allowed us to have Trinity on Beacon Fuzz in the future to enable and disable PySpec and Trinity. We've also integrated Nimbus to a bunch of different fuzzers. So a big thank you to the Nimbus crew who exposed a nice static C library for us to plug our test harness to. So we've been helping iron out a few logging and error handling discrepancies, but yeah, happy to announce that Nimbus is onboarded now. So you can check out the Add Nimbus branch on the Beacon Fuzz repo if you want more details. And we're currently fuzzing with Nimbus, Lighthouse, and ZRNT, the shuffling, the block processing, and the attestation processing. And in fact, Beacon Fuzz has potentially, most likely, identified its first crash in the compute committee helper function by the process attestation fuzzing target due to a failed assertion. So that's quite exciting. We've just raised this with the Nimbus team. We provided traces, but we should be able to provide a lot more relevant information, mostly SSZ blobs tomorrow. We've also published a couple of fuzzers on Fuzzit, which is a cloud-based fuzzing as a service platform. So mostly doing this as a proof of concept to learn more about the platform, which looks quite promising. The first couple of fuzzers are essentially free, and then you have to pay a kind of a recurring fee. We did have to adjust our build. That was quite painful, but we got there in the end. And I guess the long-term plan is once the fuzzers are stable, we'll be submitting a request to Google OSS Fuzz to basically use their infrastructure for continuous fuzzing. So I expect this to happen around the end of January. On a completely different front, we've started looking at libprotobuf mutators, which is it's basically a library that allows you to randomly mutate protobuffers. So you can use that in conjunction with guided fuzzing engines such as libfuzzer. That's the fuzzing engine we're using for Beacon Fuzz. And you basically define a proto description file for the Beacon state and instruct libfuzzer to mutate the specific fields prior to any SSZ serialization or any epoch state transition. So for those of you familiar of how Solidity compile is being fuzzed, it's extremely similar, if not very identical approach. And it's a very much work in progress. So you can check out the LPM branch if you're interested, but we're making good progress on that front as well. Happy to announce that Prashamek, also known as Crypto has joined the Beacon Fuzz team. He'll be working with us primarily on boarding Prism while having the RNT. So if you guys recall, last time I provided an update, I shared some of the challenges we were facing with some namespace clashes when compiling down to fuzzing targets. So Prashamek comes from the Eth2.0 fuzzing team, so he had to deal with a lot of similar issues. So we're very much looking forward to his input. He'll also be helping us with fuzzing coverage and optimization. That'll be his next focus after solving the namespace clashes. Yeah, we'll have a blog post next week for everyone to consume that will detail all the technical challenges we faced and the progress we've made on Beacon Fuzz. And I guess independently of Beacon Fuzz, we've also implemented an RPC fuzzer for Lighthouse, which has been running for about 7-8 days now with no crashes. So we can't integrate that to Beacon Fuzz, but I would definitely encourage all clients to do something similar. So feel free to hit me up if you want the fuzzing targets, or if you have any questions, or you can just look at the RPC Fuzz branch on the Lighthouse repo. That's it for me. Thank you.
Awesome. Thanks, Mehdi. And exciting that you found the first fuzzing issue. Proto, should we use Muskoka? Yes, no?
Yes and no. So Muskoka is built so you can like deploy as many different clients as possible while just running on a C. So you have these state inputs that get fed into the system, run every client, every consensus machine, and you get all the logs and outputs registered. So for this kind of processing, it's not the same speed as.
Oh, I know. I meant with
you could get wider coverage on clients.
With the
You
failed
start deploying more of these nodes.
With the failed SSZ blobs, can we log them in Muskoka?
Of course.
Well,
yes.
Maybe we should do that as
Cool.
an experiment.
We'll get those tomorrow. I'll share them with you, Proto.
Cool. Okay. Other testing updates. Great.
No, nothing special. So a few tests were introduced with the version updates of the spec. But if every client is passing them, then you should be fine.
Yep. Great. Client updates. We will start with Trinity.
Hey everyone. Yeah, so again, just working towards testnets, specific features. So we merged in this PR for our initial pass at attestation aggregation, which if Xiaowei is here, she can speak more too. But that was exciting. A big one was merging in updates to PySSZ. So essentially how we handle hash root calculation. And we did some small benchmarks, or at least I'll say micro benchmarks, and saw like crazy performance speed. So that's really exciting. A bunch of other laundry list of things. So like separating out our validator client, we've been making progress on that. Syncing stability in pilot P2P and the client in general, and then further work on our ETH1 data component.
Awesome. Thank you. Artemis.
Hey, I can speak for Artemis. So we've been working to get a minimum viable sync algorithm up and running. I've been making good progress there. We're hoping to be able to join a testnet soon. And as part of that, we've also been doing some refactoring of our storage layer to make that more reliable and to make sure that we can support the queries we need at the P2P layer. And we've also been continuing to work on integrating Harmony's Discovery v5 implementation into Artemis. That's all I have.
Great, thanks, Meredith. Next up, Prismatic.
Hey guys, Terrence from Prismatic. So one of our biggest achievement last 2 weeks was able to run mainnet config, which was 16,000 validators on a single beacon node in a local setup. So a lot of optimization was involved, such as we optimized our Eth2.0 service, depository, faster assignment from RPC, and the core logic. So now we're working towards a testnet restart with the version 9.2 of the spec after holiday break. So this is a big one as we're redesigning a few of our core components, such as attestation pool service, a sync service, because now we have this new aggregator role. And from the networking side, we're adding this reject all pub-sub validator to stop the automated propagation of the pub-sub message. And then the initial matrix looks good from that. And other than that, we're just fixing bugs from the testnet as they are reported by the users. And that's it from me.
Great, thank you. Nimbus.
Yes. So on the core part, we started on attestation aggregation, and we have a PR merged. We started working also on a benchmarking tool in the same vein as ZCLI. You pass it a SSZ, arbitrary SSZ state, and you can have a report on number of calls or the time it took. So hopefully it will help finding potentially slowness even at the spec level. On the sysadmin side, we are starting to get interested into how to manage a fleet of Nimbus nodes and have like kill switch reporting and such, and looking into having stack traces with less overhead because it's slowing down the processing by a lot. On the LIMP2P and networking front, so we had the LIP2P this week. We are still holding it back, and starting from next week, we'll have a mixed LIP2P daemon and LIP2P pure NIM testnet. We had some UPnP fixes, and the only blocker right now to join over testnet is disk v5. The goal is to try like the Lighthouse testnet. We are now on 0.9.3 mostly. We are waiting for the ZCLI or PySpec Genesis state to make sure that we are in line. On phase 2 part, we have Jacques, who was working on Viper in the past, that is currently looking into phase 2 for the EE and maybe on the language part and generating WASM. And side note on Eth2.0, so currently we are trying to see if we can sync with Geth parity and the normal Eth2.0 chain. We have a bottleneck in storage and sync at the moment, but we are looking into it. And we started also looking into EVMC, which is an abstract backend proposed by the Aleph team, to see if we could add Nimbus as an alternative backend to EVMC. And for the holiday break, we will have a couple of team members off.
Cool. Thank you, Mommy. And congratulations on getting the PDP integrated. It's very exciting. From there, Lodestar.
Hey, y'all. So we're still putting some final touches on our 0.9.2 branch. We should have it merged in the next few days. I guess with that one, also I have like a minimal attestation aggregation. We're working on SSZ caching, I think similarly to what Trinity is doing, and hoping that I think that's going to be really helpful for us, not only for our beacon chain, but I think it's going to help us start prototyping out like light client server, like client proof servers a little bit better, because our hash tree root has been really slow in the past. So we're looking forward to that. And we will be upgrading our libp2p soon, and refactoring based on this newer version. And that should help us with like validating incoming messages, which we have not been doing up until now.
Nice. Because this new libpdp version gives you the like validators and callback.
It just like it's like a pretty major refactor. I think I mentioned it maybe a few meetings ago, but they just kind of moved from like an older style of JavaScript to a newer style, and a lot of the APIs changed, and it's just a little more, I don't know, a little more friendly to use. And we're just going to be using it a little bit differently. So
cool. Good to hear it's getting some maintenance. Great. Lighthouse.
Hello. So we started, I guess last week or the week before, we started a mainnet 16K validated testnet. It ran for about a week. It had 4 nodes on it. It's quite small nodes on AWS, each running 4K validators. 2 of them ended up in a loop with an attestation, publishing, receiving over gossip sub loop. This exhausted the resources of 2 of them, which took 50% of the validators out. And then we stopped seeing finality. So we managed to recover it after the first outage of 100 epochs without finality by just doubling the disks and basically Control-C and up-enter again. And even some nodes that had larger disks managed to survive through the downtime and come out the other side following the head, which was pretty cool. And so after that, a couple of days later, it got into the same thing and went down. So we just kind of let it die because we figured we should probably fix the bugs as opposed to just sysadmining around them. So as a result, we're now targeting a v0.1.2 release, which has a fix for gossip loops, of course. And it also has sparse state storage in the hot database. We were doing it in the cold database before, but now in the hot too, so that we can survive for longer without finality. We also learned an interesting lesson, which might be useful for other people, that we were storing our states before our blocks, which meant that if you kill-9'd it when it was storing the state, you would have this dangling pointer of the block.state root pointing to a state that's not stored. So this made us realize our database was inconsistent, so we just swapped them around. We've added a fix to our Eth2.0 caches because we previously relied upon an archive node. So now we get all our deposit root and deposit count from the logs, not from the contract calls, because fast sync nodes will prune away old contract state. We made some API upgrades that allowed the Etherchain, beaked.in /bitfly team to launch a block explorer for Lighthouse. We've also added a bunch of stuff that the community suggested and bugs they found. Age has been busy on the networking side. He's updated Rust gossip sub for content addressed messages. He's in the process of merging gossip sub down into the main Rust libp2p library. And he started implementing the naive attestation aggregation strategy. So I think we're going to launch the new testnet tomorrow and make it public next week if all goes well. This time we're going to have more validator nodes and dedicated boot nodes so that we can be a little bit more resilient. And we're also hiring Rust developers, so check out our Twitter if you want to link to that.
Awesome. On the attestation loops, does this content addressing attestation, does that fix it, or do we know the source? Is there any learnings to share here?
I'm not sure that Age was able to fully identify what the cause of the loop was. We're going to add some more logging, so if it happens again, hopefully it won't. Then we'll know exactly what it was. We basically put in a bunch of fixes to stop it from happening. I think the content address messages helps, but that's kind of Age's domain. I haven't been in there, so I'd be speaking out of turn.
Gotcha. Can you repeat the state storage real quick and then maybe write it up? Mommy is interested. The state storage and block ordering.
Oh yeah. So if you store, so a block points to a state, but a state doesn't point to a block. So if you store the state first, and then before you store the block, and you crash, it means that you have a junk state in your database, but you don't know it's there. Whereas if you store your block first and then your state, if you crash before you store your state, you have a block there that points to a state that doesn't exist. And in our code, we return an error and kind of exit early if that happens.
Cool. Thank you. Shasper.
Yeah, so for us, we are mostly testing against, still testing against the testnet, against Prismatic. Trying to fix some syncing issues, like it's currently a little bit slow, so we try to make sure the connection doesn't drop that often, so we can sync faster, and trying to get into the discovery protocol with Prismatic using the Cadmalia. Yeah, so that's basically what we're doing, and I think the goal is to try to get into as many testnet as possible, so we can have some. Yeah, so that's for us.
Cool. Thanks, Ray. And Nethermind.
Unmute myself. Okay, so we're still quite a bit behind. We're still in phase 0. We have, for those who don't know, we're up to have the core beacon chain, full choice, SSZ, and BOS stuff. Working on this validator, have basic block creation. I'm about to do validation and then get our first look at actual peering. There's still lots of parts, so validator attestations rather than blocks, like all the storage stuff. Eth2.0 real integration. We're still only on spec 091 and no phase 1 stuff yet. So we'll catch up.
Cool, cool. And what do you intend to use for your libp2p stack?
Good question. So with one option is looking at some sort of interop with a libp2p existing integration. The other is there's a I don't know which parts are being used, but there's a library, peer talk, which is another library of different peer-to-peer algorithms. Same sort of heritage as libp2p, and the guy, I don't know his name off the top of my head, but Thomas knows him, who's worked on that.
Yeah, I can add here. So I was analyzing different approaches. So I think the main thing will be a possibility to look at the existing IPFS libp2p implementation in .NET, but it's more like 40-50% done, and it was developed probably like actively 1 or 2 years ago. So this is something to explore for us. I think we'll be just implementing C# implementation of libp2p, and we can start with connecting to one of the existing like Go daemon there was in the past. I'm not sure if this is a viable option at all, but we'll be exploring it as the next step.
Cool.
Yeah,
it works on the Go daemon. We are using it in Nimbus. It works. The main issue is that you don't control the logging part, and so some things stay hidden. And when you work on Ethereum 2, you really like to know how many peers you are connected to and stuff.
Oh, that's great news. So I think we can track the messages raw maybe, unless they are encrypted, probably encrypted. But then it will be this thing that we'll start with for sure. So the first stage is phase 0 will be on this Go daemon, and in the meantime we'll be implementing libp2p for .NET, but it all depends on like whether it will be worth the resources or the Go daemon will be enough.
Right.
Thanks for this news.
Well, and then there's potentially the option of using Rust or Nim, right, to create targets. Mami, is that?
Yeah, it's actually very easy to bind from C# to Rust or C++ libraries. So if those libraries will be sufficient, then we should have a very good quality bindings with good performance. So won't be over investing into really P2P stack for .NET. Not sure if it'll be worth it.
Mm-hmm. Cool. Thank you.
So I'll probably reach out to people as they get into that on, whatever communication to see if people have any tips or suggestions.
Yeah, cool. There's that networking channel in the Discord, which is good, and GitHub issues and things. So
Yes, and if there's some test networks up and running, we'll ping them and see what they send to us.
nice.
Cool.
Great. Thanks. I think I got everyone. No. Harmony.
Yeah, we are currently working on this folk choice stuff. Also, Anton made a couple more of simulations, and yeah, you can find his write-up in the notes to networking call, to the yesterday's call. Also, Dmitry is working on DiskV5 simulation. He evaluated an S3 simulator, and it's like it's been announced in the documentation of NS3 that it supports Python, but it apparently doesn't support. It doesn't have a good support for Python. For example, you can't just create your own application like, I don't know, DiskV5 stack and evaluate it within NS3, and probably he will fall back to Anton's to simulators that Anton has crafted. And also, what else? I've been accidentally reviewing naive aggregation attestation, found a couple of issues, filed them. So that's
great.
That's it so far.
Thank you. Okay, let's move on to research updates. To start, Joseph DeLong, do you want to discuss the new group that y'all are forming?
Yeah, sure. So we some people from Artemis and the Harmony team are merging and focusing on phase 2, phase 1 research now. We're starting January 6th. We'll be all together, but we're kind of starting now a little bit. I think Anton is working on DiskV5 simulation. No real updates yet. I think the real premise of what we're doing is trying to increase the amount of people who are working on the research aspect.
Great, and it was named
TXRX.
Cool. Great.
Thanks.
It's exciting. And I suppose, you can give updates during research or whatever makes sense in the future. Thanks, Joseph. Okay, on to other research updates. Vitalik, do you have anything for us today?
It feels in the main kind of 2 research areas right now seem to be, one is just figuring out the right short-term data availability scheme. I think the main update from the kind of chats we've had with Starkware and other people recently is that the idea of starting a Merkle route, like, it does seem like the best long-term approach, but it depends on having a Stark-friendly hash function that we can fully rely on, and that's not going to come for some amount of time. So before then, there's different options, like there's just using the 2-dimensional scheme that we've had for over a couple of years, and I even had a PR for back in the day. There is using Fry as the kind of the main ingredient behind Starks as a fraud-proof mechanism. There's some other ideas. So that's what one. That's one thing that I think we're still trying to kind of think through. Another thing is figuring out how ETH transfers will will work in phase two. And I know I've been talking separately to Will and also and the other in the other research call about this, but I mean maybe I'll just kind of repeat the problem setup for everyone. The problem setup is basically that with the kind of minimalistic structure for how the ETH2 beacon chain will work, the like cross shard messages are kind of purely a higher level concept, right? Like the base protocol doesn't know about them. It's just a bunch of Merkle proofs and code verifying other Merkle proofs. And the base protocol doesn't really even know that any of this stuff is happening. It's just entirely this higher level thing. But the problem is that like Ether, the currency, can't be an entirely higher level thing because people need to be able to use Ether, the currency, to pay transaction fees, and transaction fees have to be legible by block producers. And people want the ability to be able to kind of transfer ETH from one shard to another shard. And these transfers need to be ideally kind of completable within one slot because that's what we want to be able to achieve anyway. And the challenge basically is that we need some means of transferring ETH between execution environments and kind of between one shard and another shard, such that this mechanism is also understandable by block producers, so it's kind of at least semi-enshrined in some sense. And there's two major categories of solution to this. So one of them is to just kind of go all the way and create an relatively limited appetite for at this point. Does that impression feel correct to people, by the way? So by guaranteed cross-shard messaging, I basically mean like in shard A, you can you send a kind of cross-shard message to shard B, and then the protocol itself kind of guarantees in some way that that cross-shard message gets received by shard B and then gets executed by shard B, and there's kind of fee and gas mechanics figure it out to make sure that this kind of thing doesn't kind of at protocol level to make sure that this doesn't lead to like DOS or attack vectors, anything like that.
Yes.
It's not that there's no appetite. It's just that it just feels like very much tightly coupling in a way that is brittle, and so it would need to be demonstrated that it's not. And what if we would follow that path?
Yeah, I would second what Danny just said. It just feels tightly coupled, and then brings issues as far as the transaction, what's in that transaction on the second shard as well.
Yeah. I mean, to me, that sounds like nerd speak for limited appetite, but so if we don't do the guaranteed cross-shard messaging thing, which and it does seem like a reasonable path to go. Like it basically makes Ethereum kind of or ETH2 a step closer to being this kind of pure data availability layer. Like not quite because we also provide almost pure computation, but definitely kind of more like layer 1.5 complexity than layer 1 complexity. So if we go that route, then basically there needs to be so let's say I have a transaction in some random execution environment, and I have some ETH in that execution environment, which basically means we'll just call these execution environments with names starting with E. I don't know. Let's say I have some ETH in execution environment Eddie, and I want to send it to my account inside of Eddie on shard B. Then I send a cross shard receipt, and this is a concept that kind of Eddie understands. And this receipt gets included in a block on shard A, then it gets included in a block on shard B, and then it gets verified and kind of internal state gets updated. But then on shard B, I want to have the ability to then kind of immediately use that ETH in order to like basically pay for gas and send transactions. And the problem is that, like, first of all, block producers should not be expected to understand the execution environments because there's just lots of them, or potentially lots of them. And so, and potentially, like, it's hard to verify how many of these execution environments are actually trustworthy, whether or not their ETH is kind of backed by actual ETH. So the challenge would be, so the way to do it would be that that ETH kind of actually gets held in some special execution environment that we'll call it the ETH environment that block producers are required to understand. And then it feels like the simplest approach would be to say that the only things that can hold accounts in the ETH execution environment are other execution environments, and our block proposers. And if we do that, then basically what would happen is that you would send it. So on shard A, we would send this receipt, and then on shard B, that receipt would get in. At the same time, there would be kind of one other receipt that includes all of these different ETH transfers, and that other receipt would be that other receipt would kind of go over to shard B, and that receipt would prove that the actual underlying ether got moved from shard A to shard B, and then on shard B, when you have a transaction get executed, then that ETH would actually need to get kind of transferred to the block proposer as part of the execution. So, like, if we do this, right, then the ETH execution environments would be the only one that block producers would actually be required to understand. And it's basically taking the functionality that would otherwise have to be enshrined at protocol layer and kind of putting it into an execution environment. And that, like, it seems like it works, and there is some level of complexity, but that's essentially complexity that would have to be there anyway. The thing left to figure out is basically that there's kind of like special functionality that might have to be included to make this sort of thing work. So still more thinking on this.
Yeah, there's a lot of little intricacies there.
Yeah.
Depending on the design of the system and other things. For example, that seems like it depends upon being able to specify transactions happening in maybe a series of EEs per shard block so that you can maybe do all your ETH transfers first and then do execution on other EEs. Yeah.
Yep.
Little things like that. Okay, any questions for Vitalik on that? I'm sure we will discuss that maybe more on the phase 2 call in January. And always kind of on ETH research and stuff, so check it out. Other research updates. Let's keep this moving.
Yeah. Okay, cool. So phase 2 call coming mid-January. We'll give a date here in a bit. That one will most likely focus on discussions around cross-shard transactions, some of the things that Talik's been talking about, and likely the fee market, I think are probably the two hot topics. So the goal during that call is to really hyper-focus and use it as a brainstorming productive session. Some stuff that Quill has been up to. We are doing continued work on tooling for the contract EE to run, so we can have that running and we can play with that across shards. So we're trying to set up a kind of a plan to make the tooling to build these EEs more kind of truffle-like. So it's a lot easier for other people to dive in. So that's some things that we've been doing, and then we also need to make it quicker, because there are a lot of right now things that are slow to even run this contract EE. So we're kind of bottlenecked by our tooling right now, so we're working on that. We are releasing a first chapter of this ETH2 resource or book. So super excited about this. The draft is done. We have an outline. The first chapter, I think, is really, really good, actually. And so the whole point of this, I think, actually maybe just wait. We'll likely release it next week, or maybe the week after, since that's holidays. And I think people are going to be really excited about this. So that's all I'll say for now. We have stepped up involvement on some of the state provider relayer questions. So one of the things that I've been talking about, one of the big differences in ETH2 is that block producers don't have the state, whereas the ETH1X group is doing research around the premise that block producers or miners in ETH1 have stakes. So that's a huge difference between some of the challenges that we have. And so when we look at the fee market and everything end to end, that actually has a significant impact on everything. So Sam and Onskar are putting up a write-up soon of different directions that we think that this can go in. We're hoping that people, Danny, Vitalik, other people will kind of help make a decision on direction. So there's kind of different routes that we're thinking there. So stay tuned. There should be a write-up on ETH research there soon. Let's see, cross-shard transactions. So I've started going in on this. I'm specifically starting off by looking at ETH1 data right now, trying to bloat that, evaluate that, kind of hyper-focus on 4 of the main contracts. And one of the goals is to look at what can be parallelized right now. What practices for writing contracts in ETH1, how that wouldn't necessarily work in the ETH2 world, and then see how would we write those differently, how would we make that work, how can we reduce cross-check overhead, et cetera, et cetera. So I'm hoping, to me, this is kind of a 3-month style project that should result in a really, really good write-up on everything. So that's been started. Let's see. Also figured out collaboration with TXRX. So super excited that these guys are joining in on research efforts. So and pretty excited to collab with this group as well. So I think this will move things quicker, and I think overall is just really good for ETH2. That's all from Quilt.
Great, thank you. Other research updates?
Just one quick question. Is there any kind of working group or even people, like anyone who is kind of moving forward on figuring out details of the ETH1 to ETH2 bridge?
I don't think there's a working group yet, but we do have somebody, Mikhail, is kind of assigned to that effort and is working on it.
Okay. I think one person is fine for now, but it's just our resources are kind of highly parallelizable, and feels like it makes sense to, and if not be proactive and start thinking about this and moving toward a kind of full spec for that component even now.
Yeah, very much agreed.
Just a quick update for TXRX. I'll say we're starting to kind of narrow our research topics. That happens to be one of them, and we're going to do a workshop outside Stanford blockchain conference if people are around for that, just like we did last year. This time in particular, focusing on phase 2.
Cool. Thank you. Other research updates?
Just a quick note from my side. We are organizing an event next year in May. Is ETH Barcelona. Is a short event. This is the first time we organized this one. So it's a short event. It's a 1-day event, and we hope to have, it would be good to have some of the teams working on ETH 2.0 maybe presenting some of their updates at this event. So I will be adding the link to the current website. There is not much information yet, just to date, but we will be adding more information in the coming months.
And what is the date?
That's it. May 15 of 2020.
Great, thank you. It's exciting.
Thanks.
Justin, I think I saw you unmute.
Yeah, very quick update from me. I'm still thinking about zero-knowledge proofs. And I guess, last time I mentioned that there was this breakthrough, but it turned out that there was a silly mistake that I made that was noticed by Dan Bonnet. So, basically the problem that I'm trying to solve is to build an optimal SNOC, which has basically an optimal prover and an optimal verifier. And what we have right now is SNOCs with optimal verifiers, but not optimal provers. And the way that SNOCs are built is that you have this polynomial commitment and then the IOP. And a few of the ideas that we had a couple of weeks ago still stand on the polynomial commitment. So you can do polynomial commitments without any FFTs, and this is what makes the SNOCs suboptimal for the prover. But then you still have you still need to come up with a new way to design an IOP without FFTs. And I think that I have an IOP now that has an optimal prover, but the trade-off is that the verifier is no longer optimal. So basically, we flipped the optimality on the prover and verifier.
How suboptimal is the verifier?
It's a logarithmic number of multi-exponentiations. So actually, it's pretty good. But yeah, I still need to run through all the numbers. And the proof is like logarithmic number of G1 elements. So kind of about the size of a bulletproof, like 2 kilobytes, that kind of ballpark. Yeah. So yeah, so basically it's like it's a classic.
Yeah. Okay. I just wanted to kind of throw in, there's this kind of general question I keep having on zero knowledge proofs, which is that I just keep failing to get a good answer for why like any sublinear scheme can't just become a constant verifier scheme by just like basically recursing it over itself. And like people tell me things about kind of soundness breaking because of this, but like intuitively that doesn't make sense to me, right? Because a proof that says either statement X is true or these assumptions are broken is the same thing as a proof that says either a proof of X is true or these assumptions are broken or these assumptions are broken. Like from a first order, even like logic point of view, they just collapse into the same thing. So
yeah, I was talking to Barry and he said there's two types of cryptographers with respect to this. There's the ones that are like, oh yeah, that should just work, and there's others that are just that it just feels wrong. So I haven't seen like something very distinct as to why it's wrong other than it feels wrong.
Right.
I mean, it might be one of those like theory versus practice things, right? Where like the more theoretical side of cryptographers, they don't like the Oracle like model of hash functions at all, for example.
Yeah.
So I just wonder if it's something more of in that direction. Like maybe you can't prove stuff as easily about them.
Yeah.
So my impression is that it's not the soundness that is the issue; it's the knowledge soundness. So the extractability of the witnesses. And apparently, I think it's like the argument is basically that the extractability kind of the difficulty to extract kind of grows exponentially with every layer of recursion, and so you need to be very careful in the safety proofs. That's my understanding. But there's another problem with this recursion is that you need really heavy-handed machinery like cycles of elliptic curves, and
right, it's like a constant factor.
I mean, that's purely a practical problem, right? I mean, theoretically, you could definitely do it because it's universal computation.
No, but
Yeah,
I get
absolutely.
like one more practical example of this is like, correct me if I'm wrong, but there is a version of something bulletproofs like that has square root verification time, right?
Yes, there is, yes.
And so you could just stack that on top of itself and get a bulletproof with constant verification time. But the constant would be huge.
Right, right. Huge constants.
Okay, let's move on. Thank you. Other research updates before we move on? Great. I have an item here, highlights from the client survey. I haven't had a chance to go through these. Thank you all for submitting them. One of the things that I did see in a very cursory look is that we still need to get noiseless PTP implementations going. And I think some of this is due to some uncertainty in speccing and others just probably prioritizing. But other than that, I really, myself, Proto, maybe some others, we got to dig in and see what's there. This is for aiding in planning. This is for aiding in like figuring out where maybe we can help or others can help in resources if there's some clear bottlenecks and things like that. I really appreciate it. The initial look, it's a lot of good info there. Other thoughts on this? Things that came up that were concerning about it, things that I missed, things that we missed. Okay. Networking. The bulk of this conversation has moved to a networking call, which we've done 2 this month. They've been very productive. We'll probably do one in the second week of January. Ben's notes are posted in the agenda. Any other questions, thoughts, updates on networking that weren't necessarily covered in that call or were worth bringing to this call? Okay, excuse me. Spec discussion. Paul has a proposal, issue 1537 in the specs repo that pretty much says instead of using block depth from the head of, or block depth using timestamps to reduce the overhead of caching and the potential issues of handling reorgs locally when trying to figure out this like local version of the chain in Vue. My initial look at this, and I've talked to Paul a little bit about it, is that if it's overall a simplification on the client side, that in terms of like security and the things that we're looking to get out of this mechanism, it seems totally fine. And I don't want us all to end up on different versions of this, but I think if client A and client B implemented the different versions of it, likely we would still, in almost all scenarios, come to the same conclusion about ETH1 data, at least over time, to do the voting mechanism. Paul, do you have some items, some things you want to discuss here? I think mainly we're kind of looking for some buy-in, maybe some acknowledgement of the pain points from other clients and whether this would be something that seems worthwhile to introduce. Paul?
Yeah, so basically the current mechanism doesn't cache so well. You have to cache all the way up to the head of the Eth1 chain. Then you have to cache all of the way back to the previous Eth1 block. So that means that the size of the cache grows linearly with the time since you last managed to make a successful Eth1 vote. Then if you want to protect yourself from reorgs on the Eth2 chain, you also have to cache all the way back to the previous, the Eth1 route at the previous finalized block. So it becomes very difficult to cache. The most annoying one is basically you have to cache up to the Eth1 head, which means you have to deal with reorgs. So the proposal I've made means you can follow at 128 blocks. With the current one, even if you if you like that, there are points like at the start of the voting period where if you don't have an immediate connection to the F1 chain, your ability to vote is impaired, not massively, but somewhat. But with the thing that I proposed, you can basically not talk to an Eth2.0 node for less than the follow distance, and you'll be fine. I think clients will find that this is much easier to implement. So have a look and yeah, see if it's easier for you, if it works. It also gets rid of the beacon state read when you're the occasional one you need to do when you're voting. So I think that would make Preston happy.
And if you're not maintaining a cache, which maybe you should, this would end up being a very similar mechanism, correct, Paul? In terms of making dynamic RPC calls?
Yeah, sort of. So the problem that we have, so the weird thing about the current voting thing is you need to find a block by timestamp, and the F1 RPC doesn't support that. That's one of the reasons you need to cache. So, yeah, it'll be. Yeah, I think it's kind of different to if you're going to call from an RPC or if you're going to read from your cache. But I think I'd be very surprised if anyone ends up actually reading from the RPC for every time they produce a block, because you got to read like more than 1,000 blocks, and yeah, it's just messy.
Gotcha.
Does anyone want to say anything about that? I have something else related to Eth1 I want to bring up.
Yeah, quickly, I mean, please take the conversation to the issue, but are there any visceral reactions on this being bad and really messing up your workflow? Okay, issue 1537, try to get some eyes on that in the next like day if possible. Paul, next issue.
Yeah, so the next thing I wanted to talk about was how we have to wait for Genesis. So when the deposit contracts launch, and we have this period where we're waiting for either min Genesis time or the right number of validators to start. So this is pretty cool. We've implemented it, but it's kind of it's annoying in a few aspects. One is that it adds a whole new application state to your beacon node. So you have to have this period where you don't know what Genesis is. You can't have a beacon chain. So for us, it means that our RPC, our API expects there to be a beacon chain, so we can't start our API. And it's just like kind of all this weird usability stuff about like running a node before it even knows what the blockchain is. So it's kind of frustrating from that perspective. And it's also another, like for all of the clients, they're going to have to implement this, like listening to the Eth1 chain, then producing the Genesis state. They're all going to have to make sure they get it right, and we're all going to have to pay someone to audit it. And it seems to me like from a pure engineering perspective, and there might be like some, I don't know, like some political, like a social aspect to this that I'm not seeing, but it seems to me that it'd get us there quicker if we just said that like the EF produces, or someone produces a script that can listen to the Eth1 chain and then produce the Genesis block, and that this is like kind of like a widely easy to read, like audited once script, and then once it produces the Genesis state, then we just like drop that into our clients and then push it out there. And there's like a couple of things you can do to like, if there's a couple of edge cases there where like if you want to like, if there's like 2 days between when Genesis happens on the Eth1 chain and when it happens on the Eth2 chain, then like you would have to be at your computer to load to download the new release. But there's some things we can do with scripting there. So, but I just kind of wanted to table the idea of moving this waiting for Genesis thing outside of the beacon nodes and making it this separate thing. So there's kind of this like community, like outside of the protocol agreement on what Genesis is going to be, and then we load it into the clients.
So specifically, this is not a spec change, and two, you say, and then we load it into the clients, but that can easily be like a bash script coupled with this other script.
Yeah, that's right. I was talking to Zahari from NIM about this, and he was saying that it basically ends up being an instance of starting the beacon chain from a known trusted state, which is something we have to implement anyway. And something I didn't mention before is obviously that all of this code that we write that listens to Genesis and then launches, it basically gets thrown out after that. And I assume that anybody that wants to run like private testnets and stuff isn't going to bother with the ceremony. They'll just produce a Genesis state and roll from it. So yeah.
So I guess specifically, what's the action item?
Well, I guess the action item would be that I get that. So the clients would perhaps think about this and then all agree that, you know, we don't want to implement this waiting for Genesis thing, and then we would perhaps agree that like the Ethereum Foundation is going to do it, or maybe like 1 or 2 clients are going to do it. Yeah, I'm not sure. It's like it's not imperative, but it's one less thing that we have to do before we launch the beacon chain. I'm not sure if there's like an immediate action for it, but at least if we can just kind of think about it, and maybe if someone thinks it's a terrible idea, they can put their hand up. I can make an issue. I'll make an issue about it, I guess.
The thing is, if some people think it's a good idea, it can be done, and if someone thinks it's a bad idea, they can still use their current flow.
Yeah.
Okay. Yeah, make an issue. Nishant?
Yeah, so you want to start the chain from basically a trusted state, is it?
Yeah, that's right.
But that trusted state, so he wants to use the capability of starting from a trusted state to piggyback off of a separate script that would find that state from reading Genesis from Eth2.0.
But it wouldn't just be the same as what we're doing right now, basically. It's just abstracting that part away into a separate script.
Yeah, that's right. Like it's mainly like a kind of an agreement that it's not expected of the Eth2 clients to have to implement this thing, that there is going to be like, I think ultimately, like if all the clients don't agree that they're going to do it, it'd probably have to be someone like the Ethereum Foundation that produces the script that produces the Genesis state. Otherwise, it'd get a bit weird. Like if only one client, you know, writes this script, then we're kind of just trusting one client with it. I'm not sure.
Okay. But like doing this ceremony, it kind of like brings a bridge, you know, like you actually like properly bridge Eth1 and Eth2. If you just like, if you have this trusted state, it kind of like breaks it, right?
The software, you can also modify the script. You can do whatever. I make the issue. I guess the action item is, does somebody want to write this script? Specifically, does the EF? We can chat about it there.
All right, sounds good.
Thanks, Paul. Great. I just looked at is valid Genesis state to make sure that it doesn't trigger earlier than Genesis time, which is good. Okay, other spec items. Spec discussion. There's the, phase 1 PR, obviously, that needs love and has not gotten it. But I don't know if there's much to discuss there. Okay.
Yeah.
Okay. Final item, open discussion, closing remarks, anything. Great. Happy holidays, everyone. Talk to y'all soon. We'll plan on doing this probably, I don't know, I need to look at my calendar, but probably not the day after New Year's, and maybe the week after that. Cool. Thank you, everyone. Keep up the good work. Talk to you all soon.
Thank you.
Thanks, everyone.
Bye-bye.
Bye.
Bye.